Alright, welcome back everybody. In this video we're going to handle the last two examples from the separation of variables lesson. So we'll go ahead and we'll start with example 3. We're supposed to find a function y if dy dx is equal to y over x and y is negative 2 when x equals 0. Okay, so again, here we're looking at separation because we have the numerator of our differential, that variable shows up on the right hand side, and so we want to rearrange this so that all our y's and dy's are on one side and all our x's and dx's are on the other side, and we want to move all the y's to the left since the dy is in the numerator there, so we'll divide both sides by y, and we want to multiply both sides by x to get the dx's and x on the same side, and we end up with that. And now we're going to go ahead and integrate both sides. The integral of dy over y is the natural log of the absolute value of y plus c, but I'm going to put my c on the other side. And the antiderivative of dx over x is the natural log of the absolute value of x plus c. Alright, now in order to solve this equation for y, we're going to take both sides and raise them e to that power. So we've got e to the natural log of the absolute value of y is equal to e to the natural log of the absolute value of x plus c. And so we're going to have absolute value of y is equal to c times the absolute value of x. And this is a new c, and if you don't remember how this happened last time, a quick little refresher: when we have e to the natural log of the absolute value of x plus c, using exponent rules, that's e to the natural log of the absolute value of x times e to the c, and e to the c is just another different constant, and so we can simplify that to c times e to the natural log of the absolute value of x, which then becomes just the absolute value of x. Alright. Now I'm going to absorb my absolute value on my y into my constant, because basically as I evaluate this, if I substitute something in for x, the constant is going to change it to whatever the value of y is going to be. And so we can write this as y equals c times the absolute value of x, and I believe this is actually a typo. This is supposed to be y is negative 2 when x is 1. And so we go ahead and solve this, and so we put negative 2 in for y and 1 in for x, and we find that c is equal to negative 2, and so this function is y equals negative 2 times the absolute value of x. Alright, there's our function. Alright, on to example 4 from the lesson. This is actually from free response question number 6 from the 2014 AP Calculus AB exam. Consider the differential equation dy dx equals the quantity 3 minus y times the cosine of x. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 0 equals 1. Function f is defined for all real numbers. Find y equals f of x, the particular solution to the differential equation with this initial condition. Alright, so basically we're just going to go ahead and, since they tell us to find y equals f of x, we want to find the integral of dy dx equals the quantity 3 minus y times the cosine of x. In order to do that, we're going to use separation because the variable that's in the numerator of our differential shows up in this factor on the right hand side. So we're going to go ahead and separate. We'll divide both sides by the quantity 3 minus y, and we'll multiply both sides by dx. And now we have our equation separated, and so we're going to integrate both sides. The integral of dy over the quantity 3 minus y is negative natural logarithm of the absolute value of 3 minus y Why the negative? Well, if we take the derivative of the natural log of the absolute value of 3 minus y, applying the chain rule gives us a negative dy when we take the derivative of the quantity 3 minus y. And then the antiderivative of cosine of x is just going to be sine of x plus c. Alright, so there's the first part of my equation. Now I want to solve this for y. So I'm going to multiply both sides by this negative, which makes this negative sine of x plus a different constant. And then to get rid of the natural logarithm, I'm going to raise e to both sides of the equation. And then again, I can simplify the right-hand side here to c times e to the negative sine of x, where this c is a different c from the previous line. Alright, now I'll absorb my absolute value into my constant. I've got 3 minus y equals constant e to the negative sine of x. And then I need to solve this for y. So I'll subtract 3 from both sides. And then I'll multiply both sides by negative 1 to get y by itself. And now we have yet another different constant there. And now I need to solve for the value of c to get my final particular solution. We're told that when x is 0, y is 1. So 1 is equal to c times e to the 0 plus 3. And so c is equal to negative 2. Solving that because e to the 0 is 1, so c plus 3 equals 1, and c equals negative 2. And we end up with our final equation, y equals negative 2 e to the negative sine of x plus 3. Something that we've illustrated in these examples that I haven't really talked about, I think it's usually best practice to go ahead and solve the function for y and get y by itself before we solve for the constant of integration, because that way we can just, manipulate those c's without worrying about changing their values as we go through that process, and then just go ahead and find c on the end. That's just a general tip that I think works pretty well for me, and hopefully will work well for you. Anyway, that's the end of this lesson on separation of variables. See you guys next time. Have a great rest of your day.